Okay class, today we're going to learn about composite curve. So before we start, who knows what is composite curve?
What is composite curve? Composite curve is one of the methods used to determine the minimum energy requirement (MER) for the process energy target. It includes minimum steam and cooling water requirement. The figure shows an example of the process before integration, and the right figure shows the process after the integration takes place. Composite curve is made from two curves which will represent the cold composite curve and hot composite curve respectively. The graph will be plotted based on temperature versus enthalpy. This composite curve is also known as the TH diagram, as the curve is plotted by using T and delta H. To be more details, the curve will be constructed by dividing axis into interval based on the supply temperature and the target temperature of the process stream, and add together the enthalpy contribution hot streams and the requirement cold stream in each temperature interval. The plotted curve will represent the process stream's heat content.
This is the basic graphical procedure on how to construct the composite curve. First, we need to fix the delta T mean, and then we need to draw the hot composite curve and leave it fixed. Then draw the cold composite curve and shift it horizontally to the left until the smallest temperature difference is equals to delta T. So note that the pinch is the temperature where the delta T is equals to delta T mean. So the non-overlap on the right hand side is the minimum heating utility, where the minimum heat is needed to be supplied, where the non-overlap on the left hand side is the minimum cooling utility, where the minimum heat is needed to be removed.
Pinch analysis method. There are three types of pinch analysis method. The first one is composite curve method. This method uses a graphical approach and makes obvious the presence and location of the pinch in the system. Plotting both composite curves on a temperature enthalpy plot reveals a pinch at a point where the cold and hot curves are closer in the temperature. The composite curve can be freely shifted along the enthalpy axis. The second one is the problem table method. This method is useful when solving heat exchanger network problems manually but has fallen into disuse due to the advance of modern computing. The first step in the process is converting stream temperatures into interval temperatures. The intervals are then ranked in order of magnitude, ignoring any repetitions. So the next step involves balancing the heat carried by stream between each interval, and then any excess heat cascade over into the next lower down interval. Add heat from the top of the system, eliminate any negative values. So the amount added at the top corresponds to the hot utility duty, while the remaining value at the bottom corresponds to the heat that must be removed by cold utility. So the last one is the software method, which is computer tools for hand design method. Presently, the two previous described methods of pinch analysis are not in the wide use in industry, where the analysis is performed by specialized software such as AZMAN HS-Net, Super Target, and Unisim Exchanger Net. So automatically generated network must be properly constrained, lest an unfeasible amount of stream splits and loops be generated. There is a great value, however, in the ability of software packages to perform many tweaks and iterations to fine-tune a network. So that's all the three analysis methods that can be shared.
Significance of the pinch. Delta T mean, which is the smallest approach temperature, limits the amount of heat recovery in a process. There should be no heat transfer across the pinch. To ensure this, do not heat below the pinch. cool above the pinch or to transfer heat across the pinch. Any external cooling above the pinch or heating will result in cross-pinch heat transfer, thereby will increase the external utility requirement. There are many significant uses of the composite curve and pinch in our industry. One of it is as a guidelines for heat recovery matches. It helps to diagnose heat recovery inefficiencies, to avoid forbidden matches, and of course to maximize the heat recovery.
Okay class, that's all for today. So any questions? If no, we may dismiss now.